Welcome back. Today we will talk about the Greeks. Very often, those who approach the world of options start to turn up their noses when somebody starts talking about the Greeks. People give up the study of the subject, considering it difficult and complicated. This is not the case at all. Once the necessary skills have been acquired, it will be very easy to read the premium of an option according to the Greeks. In financial mathematics, the Greeks are actually numerical values, which are used to better understand the option price and the future opportunities. The Greeks explain the sensitivity of the option price to the various factors that make it up. The Greeks, therefore, are expressed on the at-now curve. The expiration date payoff, on the other hand, is not measurable with the Greeks. The knowledge of the dynamics of the Greeks allows us to manage any portfolio with method and professionalism. They represent the control panel of all our equipment, and they are used to have the situation under control, both present and future. The Greeks that we will see today are delta, gamma, vega, theta. Let's start from the delta. Delta indicates the sensitivity of the option premium to changes in the underlying price. To understand the delta, let's look at the risk profile of a future. ETFs, futures, and shares are linear instruments whose value and payoff are always constant. In fact, their delta is equal to 1. Regardless of any volatility there may be on the market. The example is clear. By buying a future at a price of 1,000, if the future rises 60 points, we will earn $60. On the contrary, if the future falls by 60 points, we will lose $60. The relationship is always 1-to-1. The delta of a long future is equal to 1. The delta of a short future is equal to -1. In case of options, the delta depends on various factors, first of all the strike price of the option, with respect to the underlying price. For call options the delta can vary from 0.5 to 1. For put options it can vary from -0.5 to -1. Let's see the payoff of a call. In this slide, we buy a call strike 1,000 when the underlying is at 1,000, so we are buying an ATM option at the money. We pay $40 for it. At the money call options have a delta of 0.5, which means that the option price increases by 50 cents for each dollar increase in the underlying. In fact, at 10:10, with 10 points of movement, the option price is worth $45, and the at-now line in fact reports a profit of $5. At 990 of course, the option price will be worth $35 and we will have a loss of $5. As you can see, however, the delta is not a fixed variable, but varies as the underlying varies. The more the underlying moves away from 1,000, the more the option price changes in a non-proportional way. In fact, at 10:20, we would expect a profit of $10, instead the position gains 11. At 1060 points, we would expect a gain of $30, instead the position gains 38. Conversely, at 940 we lose only $24, compared to 60 points of movement. For us, call buyers, therefore, the delta is in favor. The option increases its profit strength the more we are right. And it decreases its losses the more we are wrong. See how the value of every 10 points on the long call changes. 5, 6, 7, and 8, upwards, 5, 4, 3, 2, downwards. Well, I think the example just given is pretty clear. Let's talk about the gamma now. Gamma measures how much the delta changes as the underlying market price changes. As we have seen, the delta of an option is not a fixed value, but changes, mainly according to the movements of the underlying price. We can define the gamma as the measure of how much the delta of an option varies with each unit of price movement of the underlying. As the delta is the speed, the gamma is the acceleration. Let's take the example of our ATM call at delta 0.5. The gamma measures the acceleration of the price of the option contract. If the underlying is at 1000, for 10 points the price increases by $5, for 20 points the price increases by $6, for 30 points the price increases by $7, for 50 points the price increases by $8. The delta comes close to 1 at strike price 1240. Then the delta gradually decelerates. In fact, the acceleration of the gamma is maximum at the ATM and progressively decreases the further you move away from 1000. Therefore, we see that the gamma is maximum at ATM and very low for OTM options distant from 1000. The gamma, as we will see, is also amplified depending on time to expiry. The shorter the time to expiration, the greater the gamma on the options premium, and therefore the acceleration in option price will be more important. You have understood. Let's talk now about the Vega. The Vega measures how much the premium of an option is appreciated as the volatility of the underlying market increases. Let's take our usual ATM call option. Our call 1000 at 30% volatility has a Vega of $1.33. It means that the option price will be $41.3 if the volatility rises to 31%, and it will be 42.6 if the volatility rises to 32%. Therefore, at 60% volatility, the option price will be $80. As you can see, the at now curve in fact reports an increase of $40. Vega is positive for long calls and long puts and negative for short calls and short puts. We already know this. If we are buyers, we are favored by the increase in volatility, positive Vega. If we are option sellers, we are disadvantaged, negative Vega. Okay, let's talk now about Theta. Theta measures how much is the loss in value of the contract from one day to the next towards expiration date. It is maximum for ATM options and decreases for OTM options. We resume our call at delta 0.5. At 40 days of expiry, the call has a negative theta of 50 cents. It means that, tomorrow, the call will be worth $39.50. 2 days from now, $39. The cents become 56 per day, after 10 days, 68 cents per day, after 20 days, $1 per day, 10 days from the expiration date. In 30 days, the option loses only 50% of its value. In the following 7 days, the option loses another 25%. And, in the last 3 days, the option loses its last 25% of value. From what we have seen, therefore, for the buyer, theta is negative and therefore plays against him. On the contrary, for the seller, it is positive and it plays in favor. Thanks for your attention. See you next time.